Scientists are building a gigantic catapult on the moon that they say could send unlimited clean energy back to our planet. But how would this machine work? And would this plan even make sense? Let's take a closer look at what's going on here, and if the moon might become Earth's new power plant. The catapults planned on the moon wouldn't look anything like the ones we have on Earth. This machine would use a series of long arms to throw giant objects into space, which would then generate massive amounts of energy. This design was first proposed in 2020 by a group of scientists from China. They say their moon catapult could be used to deliver resources from the moon to Earth and other planets, as well as to orbit around our home planet or beyond. It's also important to note that this device wouldn't require any fuel to operate. Instead, it would be powered entirely by solar panels that would be attached to the moving parts, meaning that once the initial setup is complete, the energy extraction process would theoretically never stop. But let's imagine we're reliving in a world where this technology already exists and is ready to be implemented. So how exactly would this process work? If you think about the catapult, these would obviously need to be pretty huge. In fact, to even leave the moon's surface, the scientists estimate that the arm would need to be at least 165 feet long. For comparison, that's roughly the length of 2 American football fields. This large size is necessary because the device needs to launch its payload to a speed known as the moon's escape velocity, which is approximately 11,200 miles per hour. This is the minimum speed needed to break free of the gravitational pull of any celestial body. The basic way a catapult works is by storing potential energy in a system, usually by lifting heavy weights and releasing it all at once. In the case of the space catapult, however, there is no weight to lift. Instead, the kinetic energy from the spinning solar panels would be transferred to the arm and stored within its curved shape. Think of it like when you ree on a playground swing set and you get higher and higher as you go back and forth. As the arm is swung forward again and again, the potential energy from its position would increase until it reaches its peak, at which point it's ready to release. Once released, the energy would transfer back to the object being thrown and rocket it away from the moon at incredibly high speeds. However, this process doesn't happen instantaneously. It takes time to build up the momentum necessary to make the throw. The scientists behind this proposal say it would take about 2 hours to charge up the catapult before it could make a delivery. Then the actual launch itself would take another hour. At the end of the throw, the catapult would come to a stop and the entire process could begin anew. This is also where the recovered energy comes into play. The researchers state that approximately 72% of the energy used during the launch can be recovered and put back into the system. This means that the catapult wouldn't actually need as much energy to begin the process again, making the whole thing much more efficient. But just how much energy could this machine produce? Well, that depends entirely on what it's throwing. If it were only rocks, then the amount would be relatively small. However, if the payload contained elements that could be used as a power source, such as uranium, the return on investment would be much greater. In fact, if the catapult were able to throw a 150-ton mass into deep space, it could produce enough electricity to power nearly 10 million homes for 1 year. But unfortunately, it would take a lot more than one catapult to accomplish this. According to the estimates given by the scientists, the total cost of building this system would run to $18 billion. So while it would undoubtedly be useful, this machine alone couldn't save us from our reliance on fossil fuels. Another reason why the catapult makes sense on the moon rather than the Earth is because of the former's weaker gravity. As previously mentioned, to leave the moon's surface, the payload would need to reach an escape velocity of roughly 11,200 miles per hour. However, on Earth, the escape velocity is much faster at 25,000 miles per hour. This is because the moon is much smaller and has a weaker gravitational force than the Earth. In fact, the moon's gravity is about 6 times weaker than ours, meaning that it would take less energy to launch an object from its surface. The moon's thin atmosphere also helps with this. Any object launched from Earth would need to overcome the resistance of our planet's air, but the moon has almost no atmosphere to speak of. This would allow the catapult to store even more energy in its throws, as it wouldn't be wasted overcoming atmospheric drag. Finally, the moon is an ideal location because of its abundance of helium-3. This element is often referred to as the fuel of the future, as it can be used in nuclear fusion reactors. If you remember back to the Cold War, many countries were racing to develop the first hydrogen bomb, which uses fusion to produce energy. In fact, the United States was so determined to win this competition that they conducted the first ever hydrogen bomb test in 1954, dubbed Operation Castle. The device was codenamed Ivy Mike and produced an explosion equivalent to roughly 10.5 megatons of TNT. While this was a major scientific achievement, the bomb's development sparked growing concerns among U.S. officials about the ramifications of nuclear weapons. This led President Dwight Eisenhower to establish the Atomic Energy Commission in 1955, whose purpose was to oversee the development and use of atomic energy. But while the hydrogen bomb was undoubtedly destructive, the same reaction could also provide humanity with a virtually limitless supply of clean energy. The only problem is that it's very difficult to obtain the necessary materials. Most of the tritium found on Earth comes as a byproduct of nuclear weapons testing and the nuclear weapons testing and the waste from nuclear reactors. However, there is another source that scientists have recently discovered, and it's coming from the Moon. Research shows that the Moon is covered in a layer of regolith, which is a mix of dust and small rocks. Underneath the surface, there's a vast field of helium-3, which is produced when solar winds hit the Moon's surface. These particles then fuse with oxygen and silicon atoms in the regolith to form helium-3 compounds. Due to the lack of atmosphere on the Moon, this material remains on the surface where it can be collected. Estimates suggest that there could be as much as 2 million metric tons of helium-3 on the Moon at any given time. To put this into perspective, 1 kilogram of helium-3 could produce the same amount of energy as 2.5 kilograms of uranium-235. Unfortunately, currently we don't have the technology to easily mine and transport this material back to Earth. But perhaps in the near future this could change, and when it does, the catapults planned on the Moon could finally become a reality. So do you think we should try and build a catapult on the Moon? Let me know your thoughts in the comments below. And if you enjoyed this video, be sure to check out my others for even more fascinating space content. Thanks for watching, and I'll see you next time. Now, did you know that humans aren't the only animals capable of getting addicted? That's right, animals can get addicted too. Keep watching to learn what some of them get hooked on and why. You may be surprised. First up is beer. Yes, believe it or not, birds can develop a taste for beer. It all started in the Czech Republic, where locals would often feed beer to pigeons, probably because they like seeing the birds get drunk and act silly. Soon enough, the birds developed a taste for it. But wait, there's more. Seagulls have been spotted stealing beer from people. Coolers and dogs have been known to sneak into their owners' fridges just to get a taste of that foamy goodness. But alcohol isn't the only vice that animals can develop. Some species have a taste for sweets, too. Candy bars, cookies and cakes. Oh my. Animals like horses, cows and pigs have been known to get hooked on sugary treats. When they get a hold of them, they can't seem to get enough. But why do they do this? Well, it could be because they're bored. Domesticated animals often don't get enough mental stimulation, so they turn to the next best thing, food. They also don't get to enjoy the sweet taste as much as we do, so they gobble it down quickly. Finally, eating sugar gives them a temporary boost of happiness, similar to how humans feel after consuming their favorite candy bar. But it's important to keep these treats to a minimum. Too much sugar can lead to obesity, diabetes and other health problems. But hey, at least these animals aren't getting hooked on cigarettes, right? Well, not exactly. Cats have been known to get addicted to nicotine. Why? Because they love hanging out with humans. When we smoke, our cats are right there lapping up the attention. But they can't help but take a little taste of that cigarette every now and then. Nicotine is highly addictive, so it doesn't take long for our feline friends to become dependent on it. Luckily, there's no evidence that smoking causes cancer in cats, but that doesn't mean it's healthy for them. So if you smoke, please do us all a favor and quit. Our cats will thank you for it. Speaking of cats, have you ever wondered what they do all day? Watch this next video to find out what they get up to when we're not around. Don't forget to subscribe for more amazing animal videos.